And what is it with us and bullets and blocks of wood? We just can't leave them alone. We got to shoot bullets into them. Okay, so presumably the bullet's going to stick in this block of wood, and the whole thing will be moving upward at some speed, and it will fly to some change in height here, right? Right. So the collision with the block of wood will be conservation momentum, and then how high it goes will be we can either Suvat that or use conservation of energy. Okay, so the momentum equation, let's assume that this is the velocity just before it strikes the block, right? The momentum one is 0.0062 times 673 equals, and then what is that? That's going to be 1.150 plus 0.0062 times v, right? So 0.0062 times 673, right? Divided by parenthesis 1.15 plus 0.0062. Ta-da! And I get that velocity that thing has right after the collision is 3.60889 meters per second. And now I can use energy, right? So I'm going to say 1/2 mv squared becomes mgh, right? So it's got kinetic energy right after the bullet strikes, and then that goes into right now. Notice I cannot say the kinetic energy of this bullet turns into the potential energy of that, because as you know, a lot of the energy is wasted. Okay, so let's see, what are we solving for? H. So H is going to be, I guess we got to divide by G, right? So we get V squared over 2G, right? Because that's V squared over 2, and then we divide by G, right? That's going to be my H. So take that number we just got, 3.6. See how I made that 0 into a 6? 0.889. I've got to have like the worst handwriting. Divided by 2 times 9.81. Okay, so square this number. Divided by 2 divided by 9.81. And I get that the change in height is 0.6638 meters, right? Which somehow we only have 2 sig figs. I guess because of this guy only has 2 sig figs, right? Yay.